You're listening to Inside iOS Dev, show about real-world iOS development. Today with you, your host, Alex Bush. And today I have a very special guest, Sandeep Aggarwal. Hey, Sandeep.
Hey Alex.
So Sandeep and we've been working together on I joined a new company recently, several months ago, probably 4, and we've been working together on this legacy code base, or well, I say legacy. It's in production. It's not that old, and it's mostly Swift with some Objective C, but it's probably about what Sandeep, 2, 3, maybe 4 years old, right?
Yeah, I think 6 years old.
6. Oh, wow, even more. Okay. So, which means it has a lot of code, sort of the core functionality was already built out, and there's a lot of code to support. And we're working on new features as well, and fixing bugs, stuff like that.
Right.
And you, Sandeep, I think you worked on that project for quite some time too, right? Several years.
Yep. So
Yeah.
yeah.
Mhm.
So yeah, it's been like 4 years I'm working on it.
4 years. Okay, yeah. So sort of you're familiar with some parts of it, but then other parts, I believe there were other developers or other people before you or who worked in parallel. So kind of you don't know everything, but you kind of know some of it, right?
Yep.
Yeah. So and then at some point, as we were kind of getting into it and working, I actually forgot we were working on technically a bug, but I think it was a sort of a feature enabling something that wasn't working in a feature correctly or something like that, permissions wise. And what we got to was kind of skipping all the context. What we got to was um, there was a how do I explain? There was a use case. We had an object called builder, and specifically it was building, or sort of intention was to build parts. Parts are a model object in our system and our sort of domain model. Um, and what it was doing, sort of from the name of it, as I was kind of looking through the code and trying to figure out what's going on, from the name of it, it seemed like, well, it was called parts builder. So I kind of assumed, oh, that's a builder pattern, right? Implementation. And it's supposed to, well, build parts and kind of be responsible for that. And hopefully maybe adhere to Genio 4 builder design pattern, right? Sort of be at least somewhat related to it. But it turned out it was not. And it was an interesting implementation where part model object, besides just being the model object and having all the properties on it and kind of representing that domain entity in our code base, it was taking up on in one of its initializers. It was actually taking that parts builder object as a param and then extracting all the values out of it one by one that it needs to set its own properties in that for that view model. Oh, sorry, for that model, which I kind of found to be odd. And what quite often I saw in the code happen, in order to create a new part model, we would initialize the builder, and the builder would have a bunch of var, like changing variable properties on it. And then you would set, um, correct me if I'm wrong, Sandeep, but I think that's how it was. You would set those properties then after creating the builder object, and then you inject that builder object in the initializer of a part, and then the part is created, right?
Yeah, that's correct. But how I actually learned the builder pattern was like it is supposed to work for all those complex objects. Like if you want to initialize a complex object, but you want them to initialize stepwise, then only this builder pattern comes into play. I mean, it is supposed to work for on those use cases, right?
Mm-hmm. Yeah, and I think we've done some research, right? Sort of as we were doing it, kind of working on it, and we what we realized, we needed to refactor it a little bit and kind of have it adhere more to the pattern, so it can be more useful, and we decouple things. And I think, Sandeep, what you found was, as you were saying, sort of, it's in builder pattern is intended for more complex objects, right? I think like examples were, and varying objects, meaning building like one type or another type of one super type, right? Like a car and then
Yeah,
fast car, or like a house and then, I don't know, super house, right?
yeah, right, exactly. That's how I actually learned when I was reading about it. So, for example, you have to construct an house, but a house can be like a small house or a big house with more utilities in it. For example, you have to make a swimming pool in it, let's say. Then uh, then you have to initialize everything inside one in it, but actually you don't require it to do it that way. That's where the builder pattern comes. uh, it exposes the methods to do one particular thing. For example, get me a swimming pool, get me this, get me that. So in that case, you don't need to initialize everything in the same initializer, or otherwise you have to go another way of subclassing it.
I see. So how would it can you maybe sort of elaborate on how would it look like from the user perspective, user of that builder, when you kind of use the object, and what methods do you call and how, and then inside of the builder, what's supposed to happen?
Okay, so let's take the example of the house then. Okay,
Hmm.
so I want a house. Say I want a house, and so I will add some methods like build walls, build some doors, build windows, build a roof. Okay, but my friend now wants another house with a garage added to it.
Hmm.
But in the initializer of my house, I actually didn't added the garage. So what I can do is I have only one option, is to subclass that house, right?
Hmm.
But this will solve only one problem, like the garage problem. Suppose I got another friend which he wants to add swimming pool in it, right?
Hmm.
So I will have to add another subclass for it. I have to subclass the original house and then add a swimming pool to it. How this builder patterns actually solves it is, uh, you can actually don't have to initialize all these things in one single initializer. You can make some utility methods like build walls, build doors, build the roof, build garage, build swimming pool. And then according to your whim, you can call these methods in in your initializer. Or for example, I may initialize a house builder, and then I will call build wall, build door, build windows, build roof, build, and that's all. Okay, and at the last I can just call one last statement like get the result, and that will be the house, right? Similarly, when my friend asks for a garage, I will call all these methods, but an additional method again, build garage, and the last statement get result, that is in a house. Similarly for swimming pool, get build swimming pool, and the last statement get the result, the house. And that way we are not subclassing it, but we are utilizing our builder. We just need to add one single method to our builder, and boom, we get all the kind of houses we want.
Right. Yeah. And sort of under the hood, basically, to add to what you were saying, you as you initialize that builder and then call those methods that you want to call to only create parts of the house that you like, um, sort of internally inside of that builder, right? There's some property set or maybe other model objects initialized that needed. Let's say, your swimming pool is represented by another swimming pool object, right? Which is also complex on its own. That's all taken care of inside of that builder by that method add swimming pool, or something, or set
Yeah,
swimming pool.
that's actually, yeah, great example, right?
Yeah.
Now if you happen to do it in the same initializer, the overall complexity will actually get increased, right?
Mhm.
Now, but if you do it like this, I mean, passing a different initializer for even a swimming pool in this method, like build swimming pool method, then it will be too easy to implement, right?
Yeah, yeah. It's kind of a what is it called? Composition, not composition, but sort of like a composition where maybe one of the solid principles where you extend without modifying or something. You don't have to touch the house object, but you extend functionality by adding stuff to builder, sort of.
Right.
There is, of course, a caveat to it. I think if you never had a concept of a swimming pool in your code base, in your house model object, and now you want one, yeah, you probably have to at least add a modify house model object by adding a property swimming pool. Sure, but that's probably like the only addition for the most part that you're making, and then the rest of the nitty-gritty detail logic of how to add a swimming pool, if at all, to a house is all in the builder, right?
Right.
Yeah, and then at the end of the whole sort of sequence of after you called what you need to call and set what you needed to set in the builder, you would call what you were I think you said it was a get result or something. It doesn't matter what you call that method, but basically like build, right?
Yeah.
A method that would spit out and return the final model object that this builder is supposed to produce, right? Which is in this case a house.
Yes.
So yeah, and exactly. So like with that, that's the common um, builder design pattern implementation that I know of. Although at the time when we were doing it, I kind of forgot, and I remembered the other use case, which I'll tell about, and we kind of the use case that we ended up using, but it's quite similar to this. But nevertheless, given that definition, given that description of how builder's supposed to be, when we looked at our case where we have a model object, take a builder inside of its initializer as a param just to extract the variables that were set on it to construct itself, it kind of didn't make any sense.
Right.
And
Yeah.
it was sort of coupling the model too much and giving too much responsibility to the model.
I agree.
So yeah, what we ended up doing, it took maybe like a couple of iterations and interesting conversations, and that's why we decided to record this. Ultimately, what we did was close to what Sandeep was describing, with a canonical quote unquote implementation of a builder pattern, but I think I'm remembering now. It looks more or behaves more like a form design pattern. It's more from the web world, like Ruby on Rails, I think specifically world. But conceptually, it's the same. It's we use the builder pattern. Oh, sorry, builder object as a property basket, if you will. It essentially, at the end of the day, it has all of the properties that our a part model object has. Let's say name, description, quantity, whatever else, right? Each
Mm-hmm.
one of those is a let in which means it can only be set on the initialization in our model object. But in the builder, all of those are variables, vars, right? Variable properties, and I think they're even optional, right, Sandeep?
Yep.
Yeah, and so the way we use the builder now after our refactor, we initialize builder, part builder. We then pass it around, and it could, most of the time it's used immediately and all the properties that needed are set and that's it. But sometimes it could be passed around, and then, when the user enters, let's say, just the title for the part, then that's the only property that's set on that builder. Then the rest of the variables are still nils effectively. And then eventually, as the user or some other way in the system, we collect and aggregate the rest of the variables needed to actually make a part, then we call the build method. So it's builder.build, and that returns and produces a new part and returns a new part model object, right? Just like in that canonical implementation, the get result method. Conceptually, it's the same. The only difference is it's not that complicated in our case. We're really just simply setting, for the most part, primitives like strings and ints, and strings, really. But we do have that build method. It creates it, and it also has validation in it. So, for example, I think it was with part, right, Sandeep? When the
Yeah.
ID is not set, and then it won't make it.
Yeah, actually, that was quite an interesting case. Yeah.
Mm-hmm.
So what happened at that time was, so we actually added one condition that the builder should make a part only when it has got a valid ID, and that looks like correct at the first time, right? When
Mm-hmm.
anyone who will see that code will find it, yeah, that's condition is genuine, that's correct, and that should be honored every time. And it was working quite well until we realized a situation when we actually wanted to create a local part object, right? But that local part object can't have an ID at that time,
Right. Yeah.
right?
And the reason we wanted to create it, just to clarify, I believe because the user was creating a new part, right, or something like that.
Yeah.
Mm-hmm.
So for that, so now we didn't set any ID in the builder itself, and now what we but we are still uh, but we still want the builder to provide us a valid output. That's a part. But we miss that condition that it will not emit a part until unless it has got any valid ID in it, right?
Right. And I think sort of that was an indicator that this part. So uh, let me kind of give a little more context on this. That part of the code was already written, right? That wasn't the new stuff that we added. It was already there. So originally, uh, the there was a builder, and then using that builder, they would create a part, and then that part model would be passed around, and then as the user enters data, then it's like altered, right? Something like that. But as we refactored this thing, it turned out like we can't do that, right? Because that part object is now set in stone, right? It was all let variables, like, well, a model object should, right? And that was the indicator of, oh, okay, we actually need to change. That's the responsibilities change. Now the model is not the basket of values to be set on, right? It's the builder, and now we're passing the builder, and instead of using that part, and we don't need to produce it anymore, basically, we instead could be using the builder object itself. And in this case, it kind of plays a role of a form, kind of what I was referring to previously. There's a concept of a form object in the web apps, where, well, it represents that form, and every field in the form that you can set is like that object has those properties for them. Kind of in that scenario, our builder became that. It coincidentally, because the user actually enters those fields. So yeah, and I guess the point to make here is that the validation still was correct, and we still kept it instead of removing it. It was sort of, since we knew that the builder object was correct and that validation check was correct, because we kind of thought it through already from the design perspective, it informed us, like maybe other parts of the code are not, or this object is not used in those parts of the code correctly. Maybe we should use another object. So yeah, that sort of was interesting how little part of code that we redesigned then kind of nudges us and informs us on changes in other parts of the code that are, sort of not redesigned yet. So yeah, and the way we found out about this ID issue, sort of there was no compilation warnings about it. And if you think about it, how Sandeep, Alex, how did you miss it, right? It's like your build method that's supposed to produce that part object that was passed around. It's supposed to tell you, because that's an optional, right? Your build method returns an optional part, because it might be created or might not. If there is no validation checks don't go through, such as the ID being present and set, then it won't create a part, right? Well, it did not give us any warnings, and we missed it because that builder was used in Objective-C. And in Objective-C, there is no concept of an optional. There is nullable, non-nullable directives on the methods that you can set. And I forgot how they actually don't know how they interoperate with Swift. But I guess in this case, it was just silently returning nil as a result. And then Objective-C was trying to pass that nil object around, but we thought it was an actual, or rather the original code, Objective-C code thought it was the part object. And then we got a runtime bug, right? With nothing crashed, everything compiled, but we got a report a few days afterwards that, hey, this thing doesn't work anymore. And that's how we kind of found out and realized, oh, here we actually don't want to be using part model anymore, and we should be using the builder itself.
Yeah, that's why I want optionals in Objective-C.
Right?
Yeah.
I think both of us are still fond of Objective-C, but little things like optionals and maybe a bit stricter compilation checks would be nice.
Yeah.
All right. Yeah. So Sandeep, I think we covered it pretty well. Guys, if you have any questions, reach out to us at hello@insideiosdev.com or at Twitter, on Twitter at Inside iOS Dev. I believe that's the handle. Yeah, that was it. Sandeep, do you have anything you want to plug in? Any links to your blog, or how can people reach out to you if they have questions about builder pattern?
Yeah, you can reach out to me Twitter, and my Twitter handle is SandeepCool77.
Okay, great. Yeah, I'll put all of those links in the show notes so people can find it.
Thanks a lot.
All right. Yeah, Sandeep, thank you very much for coming. I hope this is we're going to cover more of the things that we discover as we work with our legacy 6-year-old code base.
Yep. Thanks for having me. I enjoyed it.
Yeah. All right, guys. We'll see you next time. Bye.